Let's take a look at systems of linear equations in two variables. And it says identify solutions. We'll talk more about that after our first problem. But we want to solve systems equations in two variables. And the first method we're going to take a look at is with substitution. So systems of equations, two variables, two equations. And we're going to solve it using substitution. Step 1, solve one of the equations for one of the variables. Step 2, plug this into the other equation and solve. Step 3, plug the values from step 2 into the equation from step 1 and solve. Okay, let's take a look at an example. Now for this video today, I went and grabbed some problems out of the book. So this first one was x plus 3y equals 5, and 3x minus 2y is equal to negative 18. Now step 1, solve one of the equations for one of the variables. It does not matter which one you pick. Usually it's the one with has a variable with no number in front of it. Notice how this first equation has an x with no number in front of it? That's usually going to be our best equation. So solve one of the equations for one of the variables. We're going to solve for x because it's the one with no number in front of it. So I'm going to take this 3y and move it over to the right side. So I got x is equal to negative 3y plus 5. Step 2, plug this into the other equation and solve. Our other equation was 3x minus 2y is equal to negative 18. Right up here we just said x is equal to negative 3y plus 5, so we're going to replace the x here with negative 3y plus 5. Okay, so we're solving for one of the variables, and then we plug that into the other one. Now when we do that, then all of a sudden we only have one variable, or we should. In this case, all we have is y's. So we're going to go through and solve this. This is a linear equation. So first step, we'll get rid of parentheses, distributive property. 3 times negative 3 gives us negative 9y. 3 times 5 is 15. Minus 2y equals negative 18. Combine like terms in any step. Negative 9y minus 2y is negative 11y. Plus 15 equals negative 18. Get everything with y on one side, numbers on the other, so I take 15 over. So I have negative 11y is equal to negative 18 minus 15. Combine numbers at a step. Negative 18, negative 15 is negative 33. And last step, divide both sides by a number in front of your y, which is negative 11. And we get y is equal to 3, not 2. There we go. Now step 3. Plug this into, or plug the value from step 2 into the equation from step 1 and solve. When I say the equation from step 1, I'm always talking about the very last line here, because it'll always be solved for the other variable. So we got x is equal to negative 3y plus 5. And we just said y is 3, so we're going to put 3 in for the y. And then we'll simplify it, solve it. Negative 3 times 3 is negative 9 plus 5, which gives us negative 4. And your answer is written in point form, ordered pairs. So we'll put -4 first, then 3 second, and that's our answer. Now, identify solutions of system of linear equations in two variables. Now that we found one of our answers, and this is specifically, doesn't say substitution, but we're still on the step 2 there, or the topic 2. To check this, what you do is you're going to plug the -4, 3 into both equations. So we got x plus 3y is equal to 5, and we got 3x minus 2y is equal to -18. Remember, this is your x and this is your y. So we're going to put -4 in for the x, plus 3 times y, which is 3. And this is a question mark at this point. We're wondering if that's equal to 5. So we got -4 plus 9. We're wondering if that's equal to 5. And -4 plus 9 is 5, so we get 5 is equal to 5. So that checks. Now it also has check in the other one for it to be our answer. So we got 3 times -4 minus 2 times 3, and we're wondering if that's equal to -18. That's -12 minus 6. We're wondering if that's equal to -18. -12, -6 is -18, so we get -18 equals -18, which then checks. So if both sides equal to each other, then that particular point checks in that equation. Now since it checks in both of them, this is our answer. Now we knew it was from over here, but that's what topic 1 is saying. Identify solutions to system of linear equations. Okay, let me clear that off. Grab a drink. Excuse me. And let's take a look at our second example. Excuse me again. 3x minus 7y is equal to 1. 6x plus 5y is equal to -17. Now we're going to look at a method called the addition method, or some books refer to it as the elimination method. Now our idea is that we want to multiply these two equations, or add these two equations together. That's the addition part. Now I'm going to go ahead and do this. It's wrong, so we'll see why. 3x plus 6x is 9x. -7y plus 5y is -2y. 1 minus 17 is -16. So we just added the equations. Specifically, we added like terms. Now the reason why this is wrong is for the second title you see in books, elimination. Our goal is to eliminate one of our variables. We still have x's and y's in our new equation, so that doesn't work. Now our goal is that when we add one of them together, they cancel each other away. And in order to do that, they have to be different signs, and they have to have the same number in front of the x or y. For example, if I want to eliminate the x's here, I'm going to multiply the first equation by -2. And then we'll talk about y. -2 times 3x is -6x. -2 times -7y is positive 14y. -2 times 1 is -2. Then we've got 6x plus 5y is equal to -17. Now if we add these, -6x plus 6x drops away. 14y plus 5y is 19y. -2, -17 is -19. Now notice that one of our variables was eliminated. The x's were eliminated. All we have now is y's. So that's the elimination. And we added. Now the reason why the x's were eliminated is because they were different signs. One was negative, one was positive, and they had the same number in front of the x. So -6x plus 6x gives us 0x, or just 0. Okay, so that's your goal. Now, we'll divide both sides by 19, trying to get to y by itself. And you get y is equal to -1. Now, at this point, you want to plug it back into one of your equations. It doesn't matter which one, whichever one looks easiest to you. So I'll plug it into the first equation. 3x minus 7y is equal to 1. We just said y is equal to -1, so we got 3x minus 7 times -1 equals 1. -7 times -1 gives us a positive 7. Take 7 over the right side, becomes a -7. Now we get -6. And then divide both sides by 3. And we get x is equal to -2. So our answer will be -2, -1. Now, if I had a different problem, I'm not going to work this one all the way down because I just made it up and the numbers don't come out nice, I suspect. Let's say I want to eliminate the y's. Well, I told you they had to be different signs, which means one of them has to be a negative. But even more than that, this is 3 and this is 4. It's not so easy to see. To figure out what to multiply by, you can always multiply by the other equation, specifically the number in front of the y. So we're going to multiply our first equation by 4. So we get 8x plus 12y is equal to 28. For our second equation, we're going to multiply it by the other number, which is 3. So this was by 4, and this is by 3. Now I said that we need one of them to be a different sign, so we'll throw a negative in here. Doesn't matter where you put it. If you put it in the 4, that's fine. If you put it in the 3, that's fine. -3 times 8x is -24x. -3 times 4y is -12y. -3 times 3 is -9. And now if you add these, 8x minus 24x is -16x. 12y minus 12y cancels. 28 minus 9 is 19. And then you would work it down from there. Like I say, I'm not going to finish that. I was just showing another example of how do you eliminate one of the variables, especially if they got numbers like that. Okay, let me clear that off. And that was system of linear equations in 2 variables. Well, let's take a look at section 5.2, systems of linear equations in 3 variables. And I got an example here I'm going to show. The example goes hand in hand with the steps. You really can't have one without the other. Okay. Now I'm going to label these. This is going to be my first equation, so I'll label that as E1. This is my second equation, so I'll label it as E2, and this will be my third equation, so I'll label it as E3. Well, we're going to and I should say, actually, this is systems of linear equations. Everything's the first power. This is systems of linear equations, where we've got 3 variables and 3 equations. Step 1. Group E1 and E2 together. group E2 and E3 together. Okay, so step 1. When I say group them together, we're going to have x minus 2y plus z is equal to -9. And we'll have 3x plus 4y plus 5z is equal to +9. And we'll group E2 and E3 together. So we'll have 3x plus 4y plus 5z equals 9. And we'll have -2x plus 3y minus z is equal to 12. Step 2. Eliminate the z's in both groupings, leaving 2 new equations, E4 and E5. So we're going to work at eliminating the z's. To figure out what to multiply it by, here's a positive 5z. If this was a negative 5z, then we could eliminate the z's. So we're going to multiply the first equation by -5. So -5 times x is -5x. This is step 2, I guess I should label. So we got -5 times x is -5x. -5 times -2y is 10y. -5 times z is -5z. -5 times -9 is +45. Now if it appears like I'm going slow through these, there's a reason. I'm not very good at them. I make a basic math error at some point. So that's why as I'm going slow, I'm double checking myself. Now in this one, we want to eliminate the z's again. This one's a positive 5z. So if I multiply this by 5, then I'd get a -5z here. So we'll multiply everything in that equation by 5. So we got 3x plus 4y plus 5z is equal to 9. 5 times -2 gives us -10x. 5 times 3y is 15y. 5 times -z is -5z. And 5 times 12 is 60. Okay, now I add the equations. -5x plus 3x is -2x. 10y plus 4y is 14y. -5z plus 5z is eliminated. 45 plus 9 is 54. And notice, these are all divisible by 2. So I'll divide everything by 2. So that gives us -x plus 7y is equal to 27. And that's E4. Well, let's add these equations together. 3x minus 10x is -7x. 4y plus 15y is 19y. 5z minus 5z cancels. 9 plus 60 is 69. Boy, these numbers are coming out strange. Appears to be right, though. Now this, I cannot divide everything by the same number, so this will be E5. Okay. We had just limited the z's in both groupings, leaving 2 new equations. Step 3. Group E4 and E5 together and eliminate the y's. Now I put it this way just so I can specifically say in a step-by-step approach what you're supposed to do. But it actually doesn't matter what variable you eliminate. It just have to be this, the variable that's easiest is usually what you pick. I'm going to eliminate the y's just so we have a step-by-step. So we got -x plus 7y is equal to 27. And I got -7x plus 19y is equal to 69. This problem, again, is a little bit easier if we eliminated the x's. all I'd have to do is multiply this first equation by -7. But I'm going to eliminate the y's. So to figure out what to multiply this by, I got 7 and 19, so you multiply it by the other one. So I'll multiply this by 19. And this one I'll multiply it by the other one, so I'll multiply it by 7. But in addition, one of them needs to be negative. So I throw a negative in there somewhere. So let's say -7. Okay, 19 times -x is negative 19x. 19 times 7. $133. 19 times 27. 513. Multiply this by -7. -7 times -7 is positive 49x. -7 times 19 is negative 133y. And this gives us negative 483. Now our step says to eliminate the y's. So we now want to add these together. Negative 19x plus 49x is 30x, I believe. 133y minus 133y drops away. 513 minus 483 is 30. Okay. Now solve for x. In this case, we have 30x is equal to 30. We'll divide both sides by 30, and we get x equal to 1. Step 2. Plug the value from step 4 into either E4 or E5 and solve for y. Doesn't matter which one you solve for. I'm going to pick E4. So I got negative x plus 7y is equal to 27. This is solve for x. This is step 5. So we're going to plug the value from step 4, which is x equals 1, into one of these equations. So we're going to have negative 1 plus 7y is equal to 27. Take negative 1 over. We got 7y is equal to 28 plus 1. And I mentioned I'm no good at these. Let's try it again. That should be 27. Take negative 1 over. Then I got 27 plus 1, which gives us 28. Divide both sides by 7. And we get y is equal to 4. Step 6. Plug the x value from step 4 and the y value from step 5 into E1, E2, or E3 and solve for z. It doesn't matter which one you pick. I'm going to pick the first one. That looks a little easier. So we got x minus 2y plus z is equal to negative 9. Okay, so we got x minus 2y plus z is equal to negative 9. In step 4, we just had x is equal to 1. So I put 1 there. Minus 2. And in step 5, we said y is equal to 4. So I put a 4 there. Plus z is equal to negative 9. And then solve for z. So 1 minus 2 times 4 is 8. plus z is equal to negative 9. 1 minus 8 is negative 7 plus z is equal to negative 9. Take negative 7 over and it becomes a positive 7. And negative 9 plus 7 is negative 2. So now we have our x, we have our y, and we have our z. So our answer will be an ordered triple where we put parentheses around it. So I got 1, comma, 4, comma, negative 2. And that's our answer. Let me grab a drink here. Now there's variations of that you can use, especially if you got some variables already missing. But this is a step-by-step approach that should work on most of the problems. I wouldn't guarantee it'll work on all of them. Some of the steps may already be done. Okay, let me clear that off. Now the next problems are partial fraction decompositions. And let's talk about the idea behind this. I got 3 over x minus 1 plus 4 over x minus 2. Now we want to get a common denominator. And the common denominator would be these two multiplied together. So it would be x minus 1 times x minus 2. And we're going to rewrite each fraction with that new denominator. Now in our first fraction we had an x minus 1, and that's still there. The new item down below is the x minus 2, so we have to multiply that by the top also. The mathematical principle behind that is wherever you multiply by the denominator, you have to multiply by the numerator. Now here, we had an x minus 2, and it's still there. We multiplied the bottom part by x minus 1, so we have to multiply the top part by x minus 1. That gives us 3x minus 6 over x minus 1, x minus 2. And this gives us 4x minus 4 over x minus 1, x minus 2. Now since they have the same denominators, I can add together the top parts. So 3x plus 4x is 7x. Negative 6, negative 4 is negative 10 over x minus 1 and x minus 2. I could even multiply those together. So we got x squared minus 3x plus 2. And we get that. So we're seeing that. This breakdown is going the other direction. We're starting with our single fraction where the denominator can be factored, and we want to end up with this. So that's our goal. And I'm not going to show you all the different varieties. The book, ebook, goes into the different varieties of this. We're going to look at negative 10x minus 11 over x squared plus 5x minus 6. Now first off, your denominator has to be factored. So this is negative 10x minus 11 over x minus 2, x minus 3. So we're going to have negative 10x minus 11 over x minus 2, x minus 3. Now, with these right here, this is, well, let me see if I can bring the table up out of the book. Although there's probably not a table actually in the book. Okay. And student view. There we go. And then bring up the textbook. And go to chapter 5. And we're talking about partial fraction decomposition. And I don't see any easy to read table out of the book, so let me just talk about it in general. If you have, and you notice it's based upon your denominators here, so if we have a two factors and they're different and they're linear, then what we do is we set you set it equal to a fraction. We put a over the first factor plus b over the second factor. So like in this problem, this would be a over x minus 2 plus b over x minus 3. Since these are the first power and they're different, then that's how you do it. Now on the other hand, let me see some more examples here. Notice here we got 2x plus 3 and x minus 2. They're both linear, they're different. So we just do a over one and b over the other. But down here, we have an x, the first power, and then we have x plus 3 squared. Now the x just has an a over it. Now the first x plus 3 has a b over it, and then the second x plus 3 squared has a c over it. So if you have multiple powers, like second power, third power, you have to put, starting with your first power, you have to have one for each one. Excuse me. Now here, now the x factor here has an a over it. The x squared plus 4. Whenever you have a second power, you always do 1 degree lower. This is bx plus c. And then that's your setup. And that's probably enough examples. You can look through here and see all the different forms. They oftentimes even have ones where you have the x squared to a second power. Not sure if I see it. Okay. Now this is a rational equation. So I'm going to multiply everything by the LCM of all your denominators. So we're going to multiply everything by x minus 2, x minus 3. Same thing over here. Multiply times each fraction. Now when we do that, these x minus 2's cancel, these x minus 3's cancel. Over here, these x minus 2's cancel, and these x minus 3's cancel. So we're going to be left with negative 10x minus 11 equals a times x, ax, a times negative 3, or negative 3a. And then b times x, which is bx, and b times negative 2, negative 2b. Okay, so now I want to put the like terms together. So we got ax plus bx, and then minus 3a minus 2b. Now we're going to factor an x out of here, but we're going to do it a little bit different than what you might think. We're going to put it behind it. So this becomes a plus b times x, and then we got negative 3a minus 2b. And I put that inside of parentheses. Now what we're going to do is we're going to equate whatever number's in front of our x here with whatever's in front of our x over here. So we're going to have a plus b is equal to negative 10, And we're going to equate our constant term with whatever we have over here, ones that don't have x's. So we're going to have negative 3a minus 2b is equal to negative 11. Now in this case we want to solve this system of equations, and I'm going to use the addition method. I'm going to multiply the first equation by positive 2. Because if I do that, I'll have positive 2b here and negative 2b here. So 2 times a is 2a, 2 times b is 2b, 2 times negative 10 is negative 20. And second equation remains as is. Now we want to add those. 2a minus 3a is negative 1a or negative a. 2b minus 2b cancels. Negative 20, negative 11 is negative 31. Then I'll divide both sides by negative 1. And we get a is equal to 31. Now we want to plug that back into one of our equations and solve for b. I'll plug it in my first equation, looks the easiest. So we just said a is 31. So I'll take 31 over then. So we got b is equal to negative 10 minus 31, or b is equal to negative 41. Now our original equation up here, we had a over x minus 2 plus b over x minus 3, and we're rewriting negative 10x minus 11 over x minus 2, x minus 3. So all we do at this point is we plug in our a and our b. So we're going to have 31 over x minus 2, and then negative 41 over x minus 3. And that would be our answer. Now there really is no reason why you do this at this point, besides just saying that it's an invaluable technique when you get into calculus, if you're going to that class. Okay, let's clear that off. And we'll look at the next topic. Get a drink. The next topic is nonlinear systems equations. So systems of nonlinear equations in two variables. And our first one we're going to take a look at is x squared plus y squared equals 25, and x plus y is equal to 1. Okay. Solving nonlinear systems of equations, and this is with substitution. Step 1. Solve the equation with the smallest powers for the variable with the smallest power. Step 2. Plug this into the other equation and solve. And step 3, plug the values from step 2 into the equation from step 1 and solve. This is substitution. Step 1, solve the equation with the smallest powers. Now the equation with the smallest powers is going to be the x plus y is equal to 1. They're both the first power. The other one has second powers on them. Solve this for the variable with the smallest power. Well, these are both the first power, so it doesn't matter which one I solve for. I'll solve for y. So I take the x over, and we got y is equal to 1 minus x. Step 2. Plug this into the other equation and solve. Our other equation is x squared plus y squared is equal to 25. Now here we just said that y is equal to 1 minus x, so we're going to replace the y here with 1 minus x. So we're going to have x squared plus 1 minus x squared equals 25. And then solve this. So we got x squared plus 1 minus x squared is 1 minus x times 1 minus x. If we FOIL that, 1 times 1 is 1. 1 times negative x is negative 1x or negative x. Negative x times 1 is negative 1x or negative x. And negative x plus negative x is a positive x squared equals 25. Combine like terms. X squared plus x squared is 2x squared. Negative x is negative 2x. Plus 1, and then I'm going to bring that 25 over the left side. And the reason why is because we got a quadratic, which means we're going to end up using the zero factor probably. So I got 2x squared minus 2x. 1 minus 25 is negative 24 equals 0. Now right away I notice they're all divisible by 2, so I can factor a 2 out. And that gives us x squared minus x minus 12 equals 0. Now these will factor using the PSD. This factors as x minus 4 times x plus 3. Now zero factor property. You get 0 on one side and you factor the other side. You set each factor equal to 0. Now you don't need to worry about setting a number equal to 0. So all we're going to set equal to 0 is the x minus 4 and the x plus 3. And that gives us x equals 4 and x is equal to negative 3. Step 3. Plug the values from step 2 into the equation from step 1 and solve. Now our equation from step 1 I'm talking about is the last line of step 1. It'll always be solved for the other variable. So we're going to plug those into y is equal to 1 minus x. So I got y is equal to 1 minus 4, which gives us negative 3. So our answer here will be 4, negative 3. Now here, I'm going to have 1 minus x, which is negative 3. So that gives us a negative, which is positive. So 1 plus 3 is 4. So this answer will be negative 3, 4. And those would be our two answers. Okay, let me clear that off. And then we'll look at our next problem. We've got 2x squared plus 3y squared equals 11. Then we got x squared plus 4y squared is equal to 8. Now we're going to solve this using addition or elimination. We've already seen that. That means we add together like terms. Now I notice that the x squareds are real close. This is a positive 2. If this was a negative 2, then we would be set. So I'm going to focus on getting rid of the x's. So I'll multiply the second equation by negative 2. So I got 2x squared plus 3y squared is equal to 11. Negative 2 times x squared is negative 2x squared. Negative 2 times 4y squared is negative 8y squared. And negative 2 times 8 is negative 16. We're going to add those. 2x squared minus 2x squared drops away. 3y squared minus 8y squared is negative 5y squared. And 11 minus 16 is negative 5. Now notice that one of our variables was eliminated. The x's were. That was our goal. So now we're going to solve this. So we're going to divide both sides by negative 5. And we get y squared is equal to 1. Now the square root property says if you got something squared equal to something else, you drop your squared and you put a plus or minus square root around the other side. And square root of 1 is 1, so we got y is equal to plus or minus 1. So now I'm going to take my two values and I'm plugging back into one of my equations. Doesn't matter which one, whichever one looks easier to you. I'll pick second equation. So we got x squared plus 4y squared is equal to 8. And we just said y is equal to 1. So we're going to have x squared plus 4 times 1 squared is equal to 8. Now 1 squared is 1 times 4 is 4 equals 8. Take the 4 over, we got 8 minus 4. So we got x squared is equal to 4. And square root property again says you drop your squared and you put a plus or minus square root around the other side, which gives us plus or minus 2. So for that one y value, we're going to have negative 2, 1, and we'll have a positive 2, 1. Now we want to do the same thing with the negative 1. So we're going to plug that into x squared plus 4y squared is equal to 8. So we're going to have x squared plus 4 times negative 1 squared is equal to 8. Now negative 1 squared is 1 times 4 is 4 equals 8. And notice these look exactly the same at this point, don't they? So if I go through and solve this, I'm going to find that x is equal to plus or minus 2, which gives us negative 2, 1, and negative 2, negative 1. And those would be our other two answers. Oftentimes when you got problems that both of them are squared like that, then it'll work out that way. You only need to plug it into one of them because the other one will give you exact same values. Okay, let's clear that off. And we're going to take a look at inequalities and systems of inequalities. Now we're going to look at this on the calculator. If you got a greater than or equal to, you'll have an upper right hand triangle. If you have a less than or equal to, you'll have a lower left hand triangle. If you got a less than or you got a greater than, you'll have a dotted line. If you got less than or equal to or greater than equal to, you'll have a solid line. And let's first solve this. Now some books will say solve this, some will say graph it. They actually mean the same thing. There's an infinite number of answers, so the only way you can solve it is by graphing it and graphically representing the answer. So we're going to plug in negative x squared into our calculator. So I'll go to y equals, clear, then negative x, and then my x squared button. Now notice where my cursor is. It's flashing right here. If I do my left arrow key, you can't do it too much. You want to put it on the first slash right here, far left. Now this is a less than, and less than up here tells us we want a lower left-hand triangle. What that means, if I press enter one time, this becomes a thick slash. One more time becomes an upper right-hand triangle, and one more time becomes a lower left-hand triangle. And that's what we wanted. Less than meant lower left-hand triangle. Then I press graph. And this would almost be our answer. We just need to know whether the line that separates our shaded from the non-shaded is solid or dotted. Well, less than up here tells us dotted line, which means this is going to be dotted, And then this right here are all of our answers. So again, there's an infinite number of answers there. And that's how you'd graph one of those. Or solve it, depending upon what the situation says. Now let's take a look at systems of inequalities. This one we got y is less than 1/2 x minus 4. Then we got y is greater than negative 2x plus 1. Now we're going to put one of them on y1, one of them on y2. Now this one has a less than. Now less than we set up here means a lower left-hand triangle. This one is a greater than, and greater than up here means an upper right-hand triangle. Okay, so I'll go ahead and put the first one on y1. So press my y equals, press my clear. Now in my calculator, I did not clear off the shading over here. 1/2 x minus 4, so 1 divided by 2x minus 4. Now if I go clear to the left here, we actually wanted a lower left-hand triangle. But if it isn't what you want, you simply just keep pressing your enter. There's not a whole lot of choices. It'll cycle through. It'll eventually get back to the regular slash there. And we wanted the lower left-hand triangle. That right there. Then I'll do a down arrow. And this one we want an upper right-hand triangle. So I'll press enter twice, and it's an upper right-hand triangle. And then we got negative 2x plus 1. Now you want to make sure that when you're done graphing these, you go back and get rid of that shading on those. So then we press graph. Now there's y1, and there's y2. Where they're both shaded is our answer. And these are both dotted lines because they got less than and greater than. And so it's be dotted, going like that, then like this, more or less. Probably should have went down more. There we go. And that would be your answers there. And that's solving a linear system of inequalities, though the same idea holds true whether you got x squared or whatever. Okay, let me clear that off. And let's talk about the last section, linear programming. And I got an example here out of the book. I got x is greater than or equal to 0. Y is greater than or equal to 0. X plus y is less than or equal to 60. Y is less than or equal to 2x. And their goal is to maximize z is equal to 250x plus 150y. And you can read the book to see exactly what does means and so forth. We're just going to look at the process here. That does not replace reading the book to see its uses and so forth. What you do is you graph each one of these on the same axis. X is greater than 0, y is greater than 0. Well, here's a right here. This is x is equal to 0. So greater than or equal to is shaded to the right. Now this one is y is equal to 0. So y is greater than or equal to 0 is shaded up. So far we're talking about quadrant 1. And then we got x plus y is equal to 60. Well, if I put a 60 here, and I put a 60 here, this line is going to pass through there, and since it's a less than or equal to, it's going to be a, do it fast so I can draw a straight line. There. Then it's going to be in this area right now. Now this one says y is greater than or equal to 2x. Well, if I put a 0 in for the x, you have to think of this as like y is equal to 2x and graphing that. So if I put 0 in for x, I'd get 2 times 0, which is 0, so it passes through the origin. Now if I plug 1 in for the x, I'd get 2 times 1, which is 2, so we want 1, 2. Now since this is 60 over here, I'm not quite sure about exactly what it would be, but let's say it's right there. So I draw a line. That would be our y is equal to 2x. Question is, what in the world is our region we're working with? If I picked some test cases, colors, purple. No, I use purple. Green, light green. If I picked a point right here, and that's not very easy to see. Okay, let me use black. If I picked a point in here, this would be like 30, 5. The question is if this is true in all of these inequalities. Or we could pick one up here. I could choose like a point right here. That's maybe 5, 30. Well, if I put in 30 and 5, remember 30 is the x. So 30 here, 30 is greater than or equal to 0, yes. I put the 5 here. 5 is greater than or equal to 0, yes. I put the 30 in for the x and the 5 in for the y, and I got 30 plus 5, which is 35, which is less than or equal to 60, so that's good. Now y is less than or equal to 2x. If I were to put 30 in for the x and 5 in for the y, 5 is less than or equal to 60, so that works. Which means our bounded area is this right here. Now for your linear programming, you're interested in every point of intersection between graphs. Here's one, and here's one. Now this one is the intersection of this green line, which we said was the y is equal to 2x, and this purple line, which was x plus y is equal to 60. You notice how I replace the inequalities with equals. Now this one right here is the intersection of the purple line, which we said was x plus y is equal to 60, and the x-axis, which is the y equals 0. Now this point right here is the intersection of the green line, which is y is equal to 2x, and the x-axis, or even the y-axis, but the x-axis, which is y is equal to 0. Okay, so we got 1, 2, and 3. Now 2 of these you can just look at and see the answer. But we said intersection of y is equal to 2x and x plus y is equal to 60. That's for our first point right up here. Okay, well, I'm going to use substitution because this is already solved for y. It says y is equal to 2x, so we're going to replace the y in the other equation with 2x. So we got x plus 2x is equal to 60. We got 3x is equal to 60, or x is equal to 20. We're then going to plug that back in one of these equations, find out what y is. I'll plug in the first one. Y is equal to 2x, so I'm going to have 2 times 20, or y is equal to 40. So this point would be 20, 40. Step 2. This one is the intersection of x plus y is equal to 60 and y is equal to 0. And I'll do substitution. I'll plug 0 in for the y. So I'm going to have x plus 0 is equal to 60 or x is equal to 60. So this point is going to be 60, 0. Now that's one of them you probably could have looked at and saw the point. This other one's obviously the origin, but let me go through the process anyway. This is the intersection of y is equal to 2x and y is equal to 0. So again, we'll plug 0 in for the y. So we got the y equals 2x becomes 0 equals 2x. Divide both sides by 2, and we get x is equal to 0. So this point would be 0, 0. Okay. Now your extreme values occur at those intersections, which means we're now going to plug each point in to z is equal to 250x plus 150y. So we got z is equal to 250 times 20 plus 150 times 40. Here we're going to plug in z is equal to 250 times 60 plus 150 times 0. And here we'll plug in 250 times 0 plus 150 times 0. Now this one gives us 0. Now over here, 150 times 0 is 0. 250 times 60. And get that, go back up. There we go. So 250 times 60. 15,000. Let's see what this one gives us. So 250 times 20 plus 150 times 40. That gives us 11,000. Now they asked us to maximize, so this is our maximum value at this point. And that's how you'd solve a linear programming problem. And that's actually the last section. So I'll go ahead and stop the recording and then answer any questions you have.